Hello there. The literal jackhammer on the ceiling above me has stopped for the day. And so we are able to record a video on solving systems by adding. Please like and subscribe for more math help. Drop a comment or question below and check out some of the other videos on the channel for help in whatever math class you are in. So the adding method, we're going to talk about some things here with the adding method for solving systems of equations. So first off, sometimes this includes subtraction, though most teachers would not demonstrate it this way. And there is a problem later in the lesson that I think I will demonstrate to you what it looks like with subtraction. But there's a reason that a lot of teachers won't do it this way. And usually they'll just say, you're going to multiply by -1 and then add. So they'll invoke the add the opposite instead of the subtraction, but you might hear this as the adding or subtracting method. Also, this is sometimes called linear combinations. So you could see that in a math textbook, that maybe that's how your teacher is what your teacher is calling it. Okay, so here's the underlying idea. If I have, say, 2 is equal to 2, which I know is true, and then I have, say, 5 is equal to 5. Okay, now those are really basic equations, like these true statements. I can add those together on either side of the equal sign. So I can add the 2 and the 5 together, and then add the 2 and the 5 together. And what I want you to note is that the statement is still true. So even though I have generated a new statement, that statement still has the same truth value as the statements coming above it. Now, here's where it might get a little bit more interesting. If you have, say, x is equal to 3 and y is equal to 7, and you add them, then the left side is x plus y, and the right side would be 10. And what I want you to notice about that is that you can add your equations going down. So if x is equal to 3 and y is equal to 7, then x plus y would have to be equal to 10. Now, both of those examples are probably pretty self-evident, but they get at the underlying idea. In other words, we can add equations vertically and the equality is preserved. And so that's the idea behind it. And when I learned this method, I think somebody just told me what to do and never really justified it, like why this strategy makes sense and why it is a viable strategy to use. So essentially what we want to do is add the equations in such a way that one of the variables will drop out. So now we've got more what we're used to looking at with systems. We have 3x minus 5y equals 8 and 2x plus 5y equals 2. And what I want you to notice about this is that this is not something that you'd want to do with the substitution method. So if you need to refresh yourself on the substitution method, please check out that lesson. I'll link it in the description. You can go back and look at that. But if you don't have a coefficient of 1 anywhere in your system, you probably don't want to use substitution. But what we can do is we can add everything on the left going down, and we can add everything on the right going down, and we will still preserve the truth of that statement. So I have 3x plus 2x, which is 5x. And then here's the critical piece. Negative 5y plus 5y is 0. And 8 plus 2 is 10. And of course, 5x plus 0 is just the 5x. So you can write 5x is equal to 10. And that's what we want to have happen. And we know that that statement will still be true because of what we just looked at on the previous slide, that you can add the sides of the equations together and the equality would still be true. And now we have something that is fairly simple to solve. We'll divide both sides by 5 and we get x is equal to 2. Now, once you get x, then you have two choices. One is to add the equations again, except this time eliminating the other variable. So this time we would try to eliminate the y by adding them in such a way that the x's are eliminated, or you can take the value and plug it into either of the original equations. So I'm going to go with this equation for two reasons. One, the numbers are a little bit smaller. So 2 is smaller than 8 and 3. And it also does not have any subtraction in it. So I'm going to try to avoid those. So we're going to plug in that 2 for the x. 2 times 2 is 4. We'll subtract 4 from both sides. So we get 5y is equal to -2, and then divide both sides by 5. So y is equal to -2/5. And there's my answer. So that's one of the ways that you can do it. And I will demonstrate on a future problem, might be the next one, where you might not want to do that. And you'll see why. I don't think I want to go that direction with it. Okay, and so that's essentially how the adding method works. So if you can add them going straight down, and one of the variables drops out, then you know this is definitely the method that you want to use. Now, what if nothing drops out? Okay, so you go to add the two equations together and you still end up with an x and a y and nothing drops out. Well, in this case, we need to multiply one or perhaps both of the equations so that a variable will drop out. So I want to take a moment and see why this is okay. So we're going to take a look at this equation. I'm going to go ahead and solve it. This is 3x minus 4 is equal to 5. And -4 plus 4 is 0. 5 plus 4 is 9. And so we have 9 divided by 3 is 3. Okay, now what I mean by multiplying an equation is you can choose to multiply your equation by pretty much anything you want. So today, I don't want to multiply. I'm looking at today's date. Well, it is June when I'm recording this, so we're going to multiply by 6. Now, what we know we can't do is we cannot multiply just one side of the equation by something. We have to multiply both sides, and you want to make sure you multiply everything on both sides. So the entire side is getting multiplied by whatever you choose to multiply by. So this would then become 18x minus 24 is equal to 30. So what I've generated here is essentially an equivalent equation with bigger numbers. So let's go ahead and solve this equation and see what we get. So I'm going to add the 24 to both sides. So I get 18x is equal to 54. And then I go and divide both sides by 18. And what we notice is we still get x is equal to 3. And so that process of multiplying both sides of an equation by something creates this equivalent equation that still will hold true because we just did the same thing to both sides, but it does change the coefficients. So instead of a 3 and a -4 and a 5, I now have an 18 and a -24 and a 30. Okay, so we're going to look at this example, and I have a note over there on the side that says, this process requires some thought and decision making. It is not as mechanical as using substitution. So this method is often much cleaner than using substitution, meaning it involves less work and it lays out on your page a little bit nicer, but it does require you to think. So you can't just go into autopilot mode with this. So what I would need to do in this particular problem, just for fun here, if I were to add these, I'd get 8x minus 1y equals 12, and you'll notice I did not have anything drop out. So we definitely have this dilemma. The first thing I need to do is decide which of the variables I would like to eliminate, and we'll go through some pointers on that, like how do you know which variable you should try to eliminate? Answer is either one. But I'm going to take a look at the x's. We're going to try to eliminate the x's. And what I see here is I have a 2 and I have a 6. Well, if I could get this 2 to be a -6, okay, if I could get that 2 to be a -6, then I could add them and the x's would drop out. So I have to think to myself, 2 times what gives me -6? Well, that would be -3. Now, I technically should write it this way. All right, I'll show you what I should do is do what I did before and show the multiplication on both sides. I tend to get a little bit lazy with that, and that's like a personal thing because it gets very cluttery to write it twice. So sometimes I will put the parentheses around the entire equation just to signify, hey, I'm going to multiply this entire equation by a -3. So I'm going to draw a little arrow and just indicate, okay, my work is going to go off here to the left. So we'll have -6x plus 12y equals -15. And then I'm just going to copy that other equation over. And now we can add going down. -6x plus 6x is 0. 12y plus 3y is 15y. And -15 plus 7 is -8. Divide both sides by 15, and I get y is equal to -8/15. Now, on the previous problem, when I got my, I think it was x is equal to 2, I said, I'm just going to go plug that in. This is not a nice number. So this is not a nice number to plug in for your y value. So you could do it this way. You could say, all right, 6x plus 3 times -8/15 equals 7, and then do the work out. Okay, that will absolutely work. However, what you might opt to do is to say, I'm going to do that same process, except this time I'm going to look at the y values. And so you might look at those y values and say, all right, I see a -4 and a +3. So I like the fact that one of them is negative and one of them is positive. Definitely like that. But in this case, I think we would have to get like a 12 there. I can't just multiply 3 by something and get a 4, or 4 by something and get a 3. So we might need to go with a 12. And that is that thought process. It requires some thought. You got to look at it and say, what do I think I need here? So in this case, we're going to multiply that top equation by a 3, because that will give me a -12y. And we're going to multiply the bottom equation by a 4. That is going to give me a +12y. And I'm going to run out of space right here. So we'll kind of do a diagonal arrow. So that's going to give me 6x minus 12y equals 15 for the top equation, and 24x plus 12y equals 28 for the bottom equation. 6x plus 24x is 30x. This time the y's cancel out because -12y plus 12y is 0. And what do I have there? I have 43. Lovely. Divide both sides by 30, and I have 43 over 30, and neither of those numbers are nice. Neither of those are friendly numbers that you would want to go and plug in. But you'll notice that the work isn't too bad. So if you take a moment and look at the screen, this isn't a huge amount of work. You've got to do some multiplication of those equations, and if you pick your numbers right, you should be able to add them going down, and you don't really care if you get a fraction because you're not going to do anything with it anyway. All right, so here are some tips for doing this. Look for common factors in the coefficients so that you only need to multiply one equation instead of both. So looking at this, I can see that 5 and 10 are, well, 10 is a multiple of 5, or you could say that they both have a common factor of 5. So I could get where I needed to go by only multiplying the top equation by a -2. Okay, so I can do -2 times 3x minus 5y equals 10 equals 10, and that would give me -6x plus 10y equals 10, which of course will add nicely with the -10y. So that's something to look for. So you always want to kind of look for, hey, can I get away with just multiplying one of the equations? Another one is look for coefficients that already have opposite signs. So in this problem, if you look at your y's are both positive, which means that when you go to multiply, you're going to have to multiply by a negative somewhere because you're going to need to get an opposite. But if you look at your x coefficients, they are already positive and negative, which means that you can avoid multiplying by negative. So that tends to make things a little bit nicer. And you can go for the least common multiple, okay? Generally, we do. We want to go for the least common multiple because we want to keep those numbers as small as we possibly can. However, if you're not sure, you can always multiply by the other coefficient. So what I mean here is looking at the 4 and the 6. The least common multiple between 4 and 6 is 12. And so your best bet for multiplying these would be to multiply by something that's going to get you a 12. So say a -3 and a +2. So that would give you -12x plus 6y equals -9, and +12x minus 14y equals 30. However, if you are not great at seeing what is my least common multiple, like, what am I aiming for there? What you can always do is just switch the two coefficients around. So you can multiply by -6 and +4. Just kind of flip them around and make sure that you're going to end up with one positive and one negative. And so that would land you with -24x plus 12y equals -18, and +24x minus 28y equals 60. And that will get you to the same spot. Okay, so if you're not great at figuring that out, you just end up with like slightly bigger numbers in the problem than maybe you would love to have, but it will still get you where you need to go. So those are some tips for just picking the best thing to do, but there are many different ways you can do them. So looking at this problem, I see two ways to do this. I can do a multiplication of either like a -2 or a -1. Okay, either of those would work. But I'm going to show you the subtraction version of this. So if you have two things that are like terms, but they're the same sign. So this is +3y and +3y, which is going to give you 6y if you add them. You can actually try to subtract them instead. And so you would subtract the bottom equation. So you would do 2 minus 4x, which would give you -2x, 3y minus 3y, which would give you 0, and 7 minus 11, which would give you -4. And then you can divide and you get x is equal to 2. Okay, now why a lot of teachers won't do that is because if you already have a negative in there, then you are dealing with subtracting a negative, which would be the same as adding, and that just tends to trip students up, okay? So that's probably why you haven't seen it, but it does work. It works on the same principle as the adding, okay? So you can subtract both sides. Now, if you're looking to do the multiplication out, I'm gonna go ahead and multiply that top equation by a -1. So that'll give me -2x minus 3y equals -7 over 4x plus 3y equals 11. -2x plus 4x is 2x, -3y plus 3y is 0, and -7 plus 11 is 4, and there's the same answer. We got x is equal to 2. Now, if x is equal to 2, that's not an awful thing for me to plug in. Like, that is not a big deal. That's not getting one of those awful fractions. So I'm going to pick one of those equations and plug it in. I'm going to pick it in put it into the top one, mostly because the top one is smaller. Subtract 4, 2 times 2 is 4. And then subtract the 4 from both sides. 4 minus 4 is 0. And I get 3y is equal to 3. And so y is equal to 1. Okay, there we go. Ta-da. And last example. This is one where we have to multiply both, and you got to choose, like, do I want to multiply by something that will eliminate the x's or something that will eliminate the y's? I'm going to start with eliminating the y's because they are smaller numbers. So 3 and 2 are smaller than 4 and 5. So I know I'll be dealing with smaller numbers, and they already have opposite signs. So I already have something that's like a negative and a positive, and I can just multiply by the other numbers. So if I have a 3 here, I'm going to multiply by a 2, and if I have the 2 there, I'm going to multiply by a 3. And so that'll give me 8x minus 6y equals 4. And 15x plus 6y is equal to 21. 8 plus 15 is 23. Negative 6y plus 6y is 0. And 4 plus 21 is 25. And right there, I am thinking, nope, I am not going to plug in 25 over 23. Like, that's awful. Not doing it. So what I'm going to do is opt to do the multiplication again, except with a different number. I'm going to try to multiply it to get rid of the x's, and you always have that option. So to get rid of the x's, 4 and 5, I'm going to need a 20. So I'm going to switch those two numbers around. So we're going to multiply the top one by 5 and the bottom one by 4. But right now they're both positioned to be positive 20. So I need to make one of them negative. I'm going to go make the top one negative. So that'll give me negative 20x plus 15y equals negative 10. And 20x plus 8y is equal to 28. Adding going down, this times negative 20x plus 20x is 0, giving me 23y is equal to 18. And divide both sides by 23, and I get y is equal to 18 over 23. So some pretty nasty answers on that one. And I just wasn't interested in plugging in 25 over 23. Years and years and years ago, I had a student who would always solve everything with substitution, no matter how messy it got. He would not do this. And he didn't have any problem with the fractions. So I was like, okay, you do you. But there you go. So you have some options. Notice that there are many different decisions you can make. So I made a decision of where to start here, but I also made a decision of which one of these should be negative. If you and your neighbor have exactly the same decisions at every single point on every single problem, it will raise some suspicions because there are many different ways you can opt to do that. So make sure that you are doing your own work when you are doing problems like this. All right, don't forget, give this video a quick thumbs up if it was helpful. Subscribe to the channel for more math help. Check out the other playlists and videos we have, and also be sure to check out the practice set for this lesson so you can practice what we went over, and drop a comment or question below. I will see you in the next one.